You were told Pompeii's victims suffocated slowly under falling ash, but forensic evidence shows many never had time to breathe their last. They died in seconds, frozen mid-motion by heat beyond human tolerance. Their bodies did not collapse gradually, they locked in place. Muscles contracted, hands clenched, faces hardened into expressions that were never meant to last for centuries. This was not a slow burial. It was a thermal shock event, a flash of extreme heat that overtook entire sections of the city faster than thought itself. And for roughly 2,000 years, that truth remained buried beneath layers of ash, interpretation, and assumption. Now, with modern forensic tools, DNA sequencing, and microscopic analysis, the final moments of Pompeii are being reconstructed with disturbing clarity. What emerges is not just a disaster, but a sequence of deaths that happened in fundamentally different ways depending on where you stood when the mountain erupted. The first real clues did not come from ancient texts. They came from bone, from residue, from fragments that should not have existed. In Herculaneum, located a few kilometers from Pompeii, researchers discovered something unprecedented. Inside the skull of a victim believed to be a young adult male, they found a black, glass-like substance. It was not stone, it was not ash. Laboratory analysis revealed it was vitrified brain tissue. Organic matter transformed into glass through exposure to extreme heat, followed by rapid cooling. This process requires temperatures of roughly 500 degrees Celsius or higher, followed by a sudden temperature drop, conditions that do not occur in ordinary fires. Only in events of extreme thermal intensity. Further analysis expanded on this finding. The glassy material preserved microscopic neural structures, offering rare insight into how quickly the transformation occurred. This was not gradual degradation. It was instantaneous alteration under conditions that overwhelmed biological limits. The implication was clear. At least in some areas, death preceded any awareness or response. At the same time, DNA analysis of victims in Pompeii began to challenge long-held assumptions. Roughly 14 individuals from what had been labeled a family group were tested. For decades, they were presented as a mother, a child, and relatives seeking shelter together. The genetic results told a different story. All were male, none were directly related. The narrative of a family's final embrace was not evidence-based. It was projection. This pattern repeated across multiple excavation zones. Identities inferred from posture or proximity often failed under genetic scrutiny. Social roles, relationships, and final actions had been reconstructed through visual interpretation, rather than measurable data. Modern sequencing disrupted those narratives with measurable certainty. Further forensic work examined bone collagen. Collagen degrades under sustained high heat, yet in many Pompeii victims, collagen remained partially intact. This suggested something critical. Many of these individuals were not exposed to peak temperatures while alive. They likely died earlier, from inhalation of toxic gases and ash, before their bodies were later subjected to heat. Additional chemical signatures supported this. Residues within the respiratory pathways of some victims indicated ash inhalation prior to death. In others, there was an absence of such markers, reinforcing the conclusion that multiple mechanisms were operating simultaneously across different locations. Trace element analysis of surrounding deposits added another layer of evidence. Variations in mineral composition suggested shifting plume chemistry over time, meaning the air itself changed in lethality as the eruption progressed. What one group inhaled in the early hours was not identical to what others encountered later. This created a contradiction. In some locations, evidence pointed to instant thermal death. In others, it pointed to suffocation, the same eruption, two very different endings. To understand why, you have to reconstruct the event itself, not as a single explosion, but as a sequence. The eruption began around midday, when a towering column of ash and gas rose into the sky. For roughly 18 hours, pumice stones rained down on Pompeii. At first, many residents stayed inside. buildings provided temporary shelter. The danger did not yet appear lethal. The stones accumulated gradually, reaching thicknesses that began to strain rooftops. Some structures collapsed, others held. Archaeological layers show this accumulation clearly. Roof tiles fractured under increasing weight. Obstructed, movement through the city slowed as pathways filled with debris. What began as a manageable situation transitioned into structural failure. Without a clear moment of escalation, night fell, but the darkness was absolute. Not the absence of sunlight, but the presence of airborne ash thick enough to block all visibility. Breathing became difficult. Entryways became still. Many remained where they were. Acoustic conditions likely shifted as well. Fine ash dampens sound, creating an environment where distance and direction become difficult to judge. Communication would have been impaired, adding confusion to already limited visibility. Then the dynamics changed. Pyroclastic surges began to descend from the volcano. These were not lava flows. They were fast-moving clouds of superheated gas, ash, and debris, traveling at speeds that could exceed roughly 100 kilometers per hour. The first of these surges reached Herculaneum. There, the temperature spike was immediate and extreme. Estimates suggest approximately 500 degrees Celsius or higher. At these temperatures, exposed human tissue cannot survive even a fraction of a second. Blood heats rapidly, internal fluids vaporize, muscles contract rapidly. Death occurs almost instantly. This is where the vitrified brain was formed. The heat was intense enough to liquefy organic material, and the subsequent rapid cooling preserved it as glass. Pompeii, however, was affected differently. The early surges lost some thermal intensity by the time they reached the city, instead of instant incineration. Many residents were exposed to toxic gases, ash inhalation, and oxygen depletion. They collapsed where they stood or where they hid. Spatial mapping of remains shows clustering in enclosed spaces. Doorways, storage rooms, and lower-level structures became temporary refuges. These locations, while offering protection from falling debris, concentrated gases and limited airflow, increasing the likelihood of asphyxiation. Environmental reconstruction suggests wind direction also played a role. Shifts in airflow would have redirected ash and gas concentrations unevenly across neighborhoods, creating microenvironments with different survival thresholds. Hours later, stronger surges reached Pompeii. By then, many victims were already dead. Their bodies were then subjected to higher temperatures, which altered posture and caused the characteristic frozen positions seen in plaster casts. Thermal exposure after death can still induce muscular contraction and structural change. This explains why some postures appear reactive, despite evidence suggesting the individuals were no longer alive when the highest temperatures arrived. This is why the evidence appears contradictory. It is not. It reflects different phases of the same catastrophe. Before all of this, the region had shown signs of instability for years. Roughly 17 years prior, a significant earthquake struck the area. Buildings were damaged. Repairs continued for years afterward. Smaller tremors persisted, but these were normalized, interpreted as routine. Infrastructure records indicate ongoing reconstruction at the time of the eruption. Walls were reinforced, columns replaced. The environment showed stress, but not enough to trigger large-scale evacuation or systemic concern. Mount Vesuvius itself was not recognized as a volcano in the way we understand today. There was no recorded memory of a previous eruption within living generations. The mountain appeared stable, fertile, its slopes supported vineyards and agriculture. Warnings existed, but they were not understood as warnings. When the eruption began, there was no coordinated evacuation, no system to move thousands of people quickly out of danger. Decisions were made individually, often based on incomplete information. Some fled early and survived, others delayed. Movement patterns reconstructed from remains suggest multiple waves of attempted escape. Some individuals were found along roads leading out of the city. Others turned back, possibly due to falling debris or reduced visibility. Decision-making occurred in real time, without reliable guidance. Artifacts found alongside victims provide additional context. Coins, keys, and small valuables indicate that some attempted to leave with possessions, suggesting an expectation of return rather than permanent flight. The fatal window was not uniform. It depended on timing, location, and exposure. In the aftermath, Rome did not preserve a detailed forensic account. What survived came largely from the writings of Pliny the Younger, who described the eruption from a distance. His account focused on observation, not internal city dynamics. Over time, Pompeii became less a site of investigation and more a site of interpretation. When it was rediscovered centuries later, the preserved forms of victims captured attention. Plaster casts created from voids left by decomposed bodies gave shape to final moments. These shapes were then given narratives. A figure holding a smaller form became a mother and child. A group clustered together became a family. Jewelry implied identity, posture implied emotion. These interpretations were not entirely fabricated, but they were not rigorously tested. They reflected assumptions shaped by later cultural values. Modern science disrupted this. DNA evidence stripped away narrative assumptions. Forensic chemistry revealed temperature exposure differences. Microscopic analysis identified tissue transformations that could not be explained by older models. Advanced imaging techniques, including high-resolution scanning, allowed researchers to examine internal structures without disturbing remains. This non-invasive approach provided additional data points, reinforcing conclusions about cause and timing of death. Isotopic analysis has also begun to reveal geographic origins of some individuals, indicating that not all victims were local residents. This introduces further complexity into the social landscape of the city at the time of the eruption. The result is a more complex picture. Not a single unified story, but a layered event with multiple lethal mechanisms. Pompeii was not a city that simply suffocated, nor was it entirely flash incinerated. It was both, sequentially, spatially varied. This matters because it changes how we understand risk, response, and human behavior under uncertainty. The people of Pompeii were not passive victims of an unpredictable event. They were individuals making decisions in a context where warning signs were present but misunderstood. Some stayed, some fled, some waited too long, and when the final surges came, there was no time left to react. The bodies preserved in ash are not just remnants, they are data points, each posture, each chemical trace. Each fragment of tissue contributes to reconstructing a timeline that had been oversimplified for centuries. What emerges is not just a more severe account, but a more accurate one. The dead were not unified in experience. Some died without warning in extreme heat. Others endured a slower collapse through suffocation. Some were already gone before the most intense heat arrived. And for approximately 2,000 years, these distinctions were blurred into a single narrative that was easier to tell but less true. Today, that narrative is being corrected, not through speculation, but through evidence. And the evidence does not comfort, it clarifies. It shows that disasters are rarely singular in their effects, that proximity, timing, and environment shape outcomes in ways that are not immediately visible. And that human interpretation, no matter how well-intentioned, can obscure reality when it fills gaps without verification. Pompeii was preserved by ash, but the truth of how its people died was preserved in something else entirely, in bone chemistry, in DNA, in glass, formed from what should never become glass. The city did not just disappear, It recorded its own ending in layers that took centuries to decode. And now that those layers are being read correctly, the final moments of Pompeii are no longer a myth of slow suffocation. They are a forensic record of rapid, varied, and devastating death mechanisms unfolding across hours that felt like minutes. Subscribe for more forensic reconstructions that challenge accepted history and uncover what evidence reveals beneath assumption. The next case examines another event where the official narrative concealed the true mechanism of death.